So this problem asks you to draw the structural formula of an optically active compound with the molecular formula. So when you are supposed to draw an optically active compound, what that means is you should have at least one chirality center in a molecule, right? And so let's say, for example, this is not what I'm trying to solve for any of the problems, but if you have at least one chirality center, then you will be able to have an optically active molecule, because this will produce a non-superimposable mirror image, which is going to therefore be optically active when it's in its enantiomerically pure form. All right. So optically active means you should have at least one structure, that is one carbon that is a chiral carbon, and it's going to produce a non-superimposable mirror image. Okay, those compounds are going to be optically active. So let's try C6H14. If you take C6H14, you can clearly see that there is no double bond equivalence, so it's going to be a hexane or an isomer of a hexane. So we can start with the known structure, hexane 1 2 3 4 5 6, and this obviously it's not going to be optically active because none of the carbons are stereogenic centers. What we can do is we can take a methyl and put this in the middle of the chain, so I can get a 5 carbon structure. I can put a methyl on the second carbon. Now if you look at this, these two methyls are the same, therefore this carbon cannot be stereogenic, and neither can any of the other carbons be stereogenic. Therefore you putting a methyl on the second carbon of the 5 carbon chain or the third is not going to give you an optically active compound either, because here also you have two groups that are identical. And if you try to say take a 4 carbon chain and put a methyl, then you have to have one more methyl to add to this chain. If you add the methyl here, that's going to be an ethyl and an ethyl, again not stereogenic center. You can put a methyl here and a methyl there, and again these two methyls are the same and these two methyls are the same, and therefore these two carbon centers are again going to be non-stereogenic centers. So for C6H14, it's actually not possible to draw a structure that is going to have a stereogenic center, and therefore it is not possible to get an optically active molecule based on this molecular formula. You can write out your possible isomeric structures you can get, but all of them are going to be compounds that will not have a chirality carbon. Therefore it is not possible to draw an optically active compound for C6H14. And so we can try the next one. So perhaps problem C. So C4H10O. So when it comes to calculating double bond equivalence, oxygen is basically same as not having it. So you can simply see that oxygen can be ignored, and you can calculate the double bond equivalence based on the carbons and hydrogens only. So C4H10 is going to have 0 double bond equivalence as well, even after you ignore oxygen. Therefore this is going to be a compound that will not have a cyclic structure or that cannot have a double bond. Okay, so I can start with a 4 carbon chain. I can add an OH here, so that is carbon 1 2 3 4. If you calculate the if you add up the carbons and hydrogens, it'll match C4H10O. Now this cannot be an optically active molecule. Now I'm going to switch the hydrogen to the second position in the chain, and now this can be an optically active compound because you have one stereogenic center. So this will be an optically active compound. You can even draw its enantiomer, so you can switch the OH and the hydrogen. This is going to be again an optically active structure. If you put the OH here instead of here, you will basically get the same molecule. Therefore you can write at least one structure for this given molecular formula. Okay, so C4H8Cl2. So again I will draw chlorine is same as hydrogen. So if you look at this, this is equivalent to saying you have C4H10, so only 0 double bond equivalence, and I can probably have a chlorine here and a chlorine there. That makes this carbon a stereogenic carbon, and therefore this structure is going to be an optically active structure. This carbon is not going to be stereogenic, but this will be. So for this problem, We solved this in the class. We tried to assign priorities based on the CAN in gold pre-log system. So let's say, for example, start with one of them here so that we can go to the next problem here. So in case, let's say you have to choose D. So if you have a carbon and you have an SH on one side, a CH2, let's say CH3 here, a CH2Br, and CH2OH. Okay, CH2Br. Okay, so the first priority among these four groups is going to be the sulfur, because you have to look at the stereogenic carbon, and the first atom attached to these ones are sulfur, carbon, carbon, carbon. So sulfur is higher in atomic number than any of these, therefore it is the highest priority. And between these three remaining groups, carbon, 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 therefore it's a tie. Carbon with 3 hydrogens, carbon attached to a bromine, and carbon attached to an oxygen. So carbon here is attached to 3 hydrogens, bromine and oxygen. So therefore this is going to be higher priority between the remaining 3 groups. Therefore this is second. And between CH3 and CH2OH, this is going to be third, and this is going to be fourth. Okay. Alright, so now I'm going to segue this into the next problem. So they say that assume that the 4 groups in each part of the problem 5.34, which is this one, are attached to one carbon. Okay, so based on that, draw a 3-dimensional formula for the S configuration of the molecule in 5.34 C and D. So since we chose D, I'm going to go with this. So we want to get an S center, and the S center should have and the chirality center should have an S configuration. So I'm going to just draw the wedge and broken wedge. So let's say we have the wedge here and the broken wedge is over here. So I want to have the 4th priority group here, and now the remaining 3 groups has to be in counterclockwise direction. So I'm going to have 1, 2 and 3. Therefore 1 is your thiol, SH. Second priority is your CH2Br. So that is your CH2 and bromine, and third priority is your CH2OH, so CH2OH. Okay, and fourth priority is CH3. So this molecule is going to be an S centered optical rotation molecule, S centered molecule.